Okay, welcome back everyone to another video. In today's topic, we're gonna be covering the method of solution by variation of parameters. So this method applies for second order non-homogeneous linear ODEs. As you can see, we have seen this method already in the previous sections where we were working with the method of undetermined coefficients. However, this method, it's a little bit different. It's a more general approach. You can see in this one, we have this formula that's presented here to find our YP. So instead of using a table, we basically just apply this formula and it will give us our solution, our YP, our non-homogeneous solution. And you can see we also, in this formula, we are using the Wronskian. As we saw in a previous video, we need to find the Wronskian for in order to find our solution. So once again, this method, the only difference between this one and the undetermined coefficients is how to find the non-homogeneous. So whenever you start problems using variation of parameters, you start, like always, solving the homogeneous solution. And then when you need to find the non-homogeneous, you will apply the equations as opposed to reading the table. So you can see this method, it's more broad, meaning it's more general, and thus can be used to solve all second order non-homogeneous equations, regardless of how they look like, whether they're Cauchy-Euler, constant coefficients, etc. And also regardless of whatever the term R of X is. So you can see we can use this method to solve equations that the R of X can be found in the table, just like the ones we have been solving, but also it can be used to solve for those terms that are not found in the table, as we will see in the example following. So once again, this is solution by variation parameters. Let's do a couple examples and let's see how well we can understand this. Okay, so we have this problem here. We have y double prime plus y equals to cosecant of x. So let's solve this problem. We know the second order ODE non-homogeneous. So as always, our first step is to solve the homogeneous of this. So the homogeneous will be y double prime plus y equals to 0. And solving this, we're going to find the characteristic equation. And we know that it will be lambda squared plus 1 equals to 0. So we get lambda squared equals -1. And if we find the square root, we're going to get that lambda 1 and 2 is going to be equal to plus or minus I, which makes this the pure imaginary and a case 3. And therefore, my homogeneous solution, YH, it will be A cosine of x plus B sine of x. And this will be my homogeneous solution for this problem. Now, what I need to find now, it's my non-homogeneous, and this is where we're going to be using this new method. So for my non-homogeneous, my R of x, in this case, is cosecant of x. And let's just check our table just to make sure. So you can see that we cannot use the previous method. So once again, here's the table. You can see that we have exponential, algebraic, and cosine and sine, but we don't have a cosecant. And even if we switch it to like 1 over sine, it's still not as given here. So we cannot use this method, and therefore we need to use the method of variation of parameters, in which we're going to be using the equation that we just talked about. So for this equation, let me just write it here. So we have that YP is equal to negative Y1 integral of Y2 times R of X over the Wronskian dx plus Y2 times the integral of Y1 times R of X over the Wronskian dx. So we need to solve this equation. You can see we need to find the Wronskian. So to do that, let's find our Y1 and Y2. So I'm going to say here that Y1 is equal to cosine of X, and that Y2 is equals to sine of x. Once again, it doesn't matter which one you choose as your y1 and y2. You can choose them backwards. It won't make much of a difference, just that your Wronskian will have a different sign, but doesn't really affect your problem. So my Wronskian, I know it's y1, y2, y1 prime, y2 prime. So finding the determinant, we have here cosine of x, sine of x, negative sine of x, right to the derivative, and cosine of x. So finding this derivative, we're gonna find the cross, you know how we find the multiplication of the products. And this is equal then to cosine of x times cosine of x minus, and the two in red, which will be negative sine of x times sine of x. And from here, we're gonna get that this is equal to, if you see the first one will be cosine times cosine, that's cosine square of x. And then that minus and minus will make it a plus sine square of x. And we know that when we make this two, this is equal to 1. And this is my Wronskian. My Wronskian is equal to 1. So let's plug it in back into our equation. So I'm going to have it here then, over here. So I have yp, it's equal to negative y1, which in this case will be negative cosine of x, times the integral of y2 sine of x times the r of x, which in this case it will be cosecant of x, and dx, and all of it under 1, right? So all of it over 1, because it's the Wronskian, but because it's 1, I'm not going to write it. And then plus y2, which will be sine of x, integral of cosine of x times cosecant of x dx, and that's it. Also under 1. So to solve this, how do we do? So we use integration by parts. Sometimes you might need to. At least for this case, we don't if we know what we're dealing with. So you can use identities. So I'm just going to copy this straight down. So this is negative cosine of x, integral of, in this case, I have sine of x, and cosecant. If you remember the identity for cosecant, that's 1 over sine of x. So we can cancel basically this one out. And then we have plus sine of x, integral of, and then we have cosine of x. And once again, cosecant, that's 1 over sine of x dx. So let's rewrite this. I think there's space. So this is equal to negative cosine of x, integral of 1 dx. Because of the sine over sine, it's not basically, it's not a 0, it's a 1, right? And then this is plus sine of x times the integral of cosine over sine, that's cotangent of x dx. So once we solve that, we're gonna get, then this is equal to negative cosine times negative cosine of x times x. And then we have plus sine of x times the integral of cotangent of x. If we find it in our book, we find the, on the tables, integration tables that we can find in the front of a book. The integral for cotangent of x is equal to ln of sine of x. And yeah, that's basically what we should be getting here. And this is equal to our y particular, or y non-homogeneous. And now to find our answer, we're just gonna combine both of these results to find our general solution. So let me write it here. So then my general solution, I have y of x. It's equal to, what did we get on top first? It was a cosine of x plus b sine of x minus x cosine of x plus sine of x times ln of sine of x. And this big equation solution, it's my general solution for this problem. You can see this problem is not difficult at all. It's just maybe a slightly longer method, but other than that, it's pretty straightforward. First half of it is exactly the same. And just the second one is just a matter of plug and chug and do integration. So let's do one more problem in the next video, and then hopefully you guys get this pretty straightforward.